This is example number 3 from exercise textbook. What is given here that PQ is a chord whose length is 8. So we can see that this is PQ, the chord, and the length is 8 of a circle whose radius is mentioned as 5 centimeter. Further, we have two tangents drawn, that is TP and TQ, from the same exterior point. And what we have to get is the length of this tangent TP. Now, before we proceed, we must write down the given. First of all, what we have to prove is TP is equal to TQ. Well, there is a construction that is needed to be done. We'll be joining O to OT here, right? And which intersect PQ at R. That might not be given in the question. So we'll be writing this construction as I have written here. Now, in the proof part, I'm going to write some statement here. The statement, if you write, you can reduce the working, or because this sum is very long. So what is the construction, sorry, the proof part, you just need to write down that the line joining the center to the exterior point of the tangent is the perpendicular bisector of the chords chord made by joining the point of contacts. This is what you'll be writing, that the line joining the center of a circle to the exterior point of the tangents are the perpendicular bisector of the chord between the point of contact. So if you write this way, you can avoid the working of the question. Now, in the later part, what we are going to do is that we know that radius is perpendicular to the tangent at the point of contact. And the second is that this we have already proved, right? We have proved. Let me first tell you that we have proved that TP is the perpendicular bisect, TO is the perpendicular bisector of PR. So if this whole length is 8, right? We know that this whole length is 8 here. So what we can say that this part, this will be 4. That means the length of PR. So this length, we got this as 4 unit. Now, we have this angle given as 90 degree here. We proved 90 degrees. So we can apply Pythagoras theorem in this triangle and can obtain the length of RO. You know that 3, 4, and 5 by Pythagorean triplet. So we got this length. This length we got as 3 centimeter. Okay, so this you can do. That's a very easy part. Now later we have to find out the value of TP. So what I'm going to do is to consider TR as X. So if I consider this length as X, what I'm taking is this length as X only and applying Pythagoras theorem. So first thing that I'll do is to apply Pythagoras theorem in this triangle. That is, say, if I take which triangle, all right? Let's say if I apply Pythagoras theorem in this triangle. So I need to mention the triangle here. The triangle is TPR. So we have one angle as 90 degree, that is angle PRT is equal to 90 degree. So we can say that the square of the hypotenuse, and what is the hypotenuse here, is TP. So TP square will be what? It will be X square plus 4 square. So I mark it equation 1. Now consider another triangle. This time you consider this triangle, that is, this is also a right angle triangle, right? The reason is radius is perpendicular to the tangent at the point of contact. So this angle is what? This angle is 90 degree here. Let me show it again to you. Here the triangle I'm considering is this one. And since radius is perpendicular to the tangent at the point of contact, I can say angle P, right? Angle P is equal to 90 degree. And the reason for this is radius is perpendicular to the tangent at the point of contact, that you may write. So here also I can apply Pythagoras theorem. So this time the hypotenuse will be what? The side opposite to 90 degrees, the hypotenuse, right? The side opposite to 90 degrees, the hypotenuse. So hypotenuse here is written. So I can say that the hypotenuse, which is X plus 3, or should I write the name? I should write down TO square is equal to TP square plus OP square. That's what the Pythagoras theorem. Now, what is TP? As you can see from the figure, TP is x plus 3. So it's going to be x plus 3 square is TO is x plus 3 and TP is what we have to get. So let it be as it is. Plus OP is very well seen, can be seen from the figure. It's 5. So it's 5 square. Later, what I'm going to do is to expand this applying a plus b whole square. So it's going to be x square plus 2ab, that is 6x plus b square is equal to 9. And transposing 5 to the other side, that square of 5 is 25 on the left hand side, is equal to TP square. Now you need to figure out that if I mark this equation as 2 here, what you can see that from equation 1 and 2, we have both TP squares. So therefore, this can be equated with this. Now, if I do so, what I'm going to get here, let's say, if I equate these two equations from 1 and 2, you may write in the exam, from 1 and 2, right? The equation 1 and 2, I can write x squared plus 6x plus 9 minus 25 is what? Minus 16. So this I can write straight away minus 16 is equal to this. And what is this? This is x squared plus this is 4, right? So 4 square is 16. We know that opposite side, same sign get cancelled. So we can cancel this. So on further simplification, we can say here that 6x is equal to transposing this 16 to the other side. It will be 16 plus 16, that is 32. That implies x is equal to 32 over 6, right? 32 divided by 6 is same as 16 over 3 on reducing. Now we got the value of x here. But then what we had to get was the length of TP, right? So now if I replace this x over here, right? In this equation, I'm going to replace x or substitute x with 16 by 3. That should give us the length of TP. So TP square is what? X square, and x is 16 over 3. So this is 16 over 3 whole square. That is 16 by 3 whole square. Whole square plus this is what? 4. So that is equal to 4 square. Now with further simplification, we can say 16 square is what? 256. So it's going to be 256 over 3 square is 9 plus 4 square, that is 16. So we'll say that TP square on taking LCM, it is 9. This is 256 plus 16 into 9 is what? 144. Let's say adjust it over here. This is TP square is equal to, this is how much? 400, right? So this is going to be 400 over 9. And if I find the length of TP, I'll have to get the square root of this. And square root of 400 is 20 and the square root of 9 is 3. So we'll say we got the length of TP. This is what we had to get. So the length of TP comes out to be 20 over 3 centimeter.